Hey, hey from West Virginia. Someday I'll get there. Anyways, but I do have joke of the day and I know you're ready for it. So, what do you call someone with no body and no nose? No body and no nose. Nobody knows. Okay, but what we do know is how to work with radicals. So let's take a look at this concept of radicals and what they mean. So you understand what squaring means, and you know that when you see 3 squared, it means 3 times 3. In other words, squaring means it times itself. 3 squared, 3 times 3 would give me a 9. And by the similar idea, 5 squared would mean 5 times 5. 5 times 5 is going to give me a 25. Well, just like addition has a reverse operation, which is subtraction, and just like multiplication has a reverse operation, which is division, squaring also has a reverse operation. We call that finding the square root. So the definition says if b squared equals a, in other words, 3 squared equals 9, then b, this number that is being squared, or in other words, the 3 that is being squared, is the square root of a. So in other words, if 3 squared is 9, then 3 is the square root of 9. Or if 5 squared is 25, then 5 is the square root of 25. So the square root symbol looks like this. And frequently we will call this square root, and it indicates to take the square root, but the symbol itself is called a radical. The number underneath the radical is what we call a radicand. So now there's 3 different formats to this square root symbol, or in other words, the radical. The one that we're familiar with looks like this. However, let's think about what's happening here. If I'm taking the square root of 9, and when I try to take the square root of 9, what I'm asking myself is, what number would I multiply to itself to create a 9? Because remember, 3 squared is 9. So what number would I multiply to itself to create a 9? Yes, 3. However, there's actually another number that I can multiply by itself to create a 9. Think hard. What about a negative 3? Negative 3 times negative 3 will give you what? Yes, negative 3 times itself, negative 3 times negative 3 will still give me that positive 9. So there are actually 2 square roots of 9. There is the positive 3, and there is as well the negative 3. Similar idea here with that 25. If I want to take the square root of 25, and I'm asking myself, what would I multiply by itself to create a 25? Well, positive 5 times positive 5 will certainly give me a 25. But what about negative 5 times negative 5? Yes, negative 5 times itself, negative 5 will also give me a positive 25. So in other words, there are 2 square roots for those numbers. So these symbols will break that down. And if I see this symbol, positive or negative square root, what that indicates to me is I'm talking about both square roots. I'm talking about the positive and the negative square root, both of them. However, if I'm looking at this symbol, notice the negative out front. What this symbol means is I recognize that there are 2 square roots. However, I'm only worried about the negative of the 2 square roots. So this would indicate the negative square root. Now, the top one, notice that there's no symbol in front of it. And just like if you saw, say for instance, a 9, you would know that indicates positive 9. If you saw a 25, you would know that indicates a positive 25. So when there's not a negative or a positive in front of it, it's understood to be positive. So the same thing is going to happen right here when we see this one. This one is going to indicate only the positive square root. Again, recognizing, yeah, there's 2. There's 2 numbers that I can multiply together to get the number underneath. But I'm only focusing on the positive square root. Now, because this one is utilized an awful lot, it has a special name, and that special name is principal square root. Principal square root. Again, because it is utilized an awful lot. So it is called principal square root. So let's take some examples of this. Notice that I've got 5 examples sitting here. And this first example looks very much like this. So it recognizes when I'm asking what would I multiply by itself, What would I multiply by itself to create a 36? Yes, a 6 times itself. 6 times 6 will give me a 36. However, this is indicating, yeah, there's a 6 and a negative 6, because negative 6 times negative 6 will be a positive 36. But this says I'm only worried about the positive end of that. So I'm just going to look at the positive 6. As opposed to what we see right here. Once again, this is asking what would I multiply by itself to create a 169. Well, a 13 times 13 will give me a 169, but as well a negative 13 times itself, negative 13. Negative 13 times negative 13, negative times negative is positive. So a negative 13 as well is the square root. But this says, okay, there's 2 square roots, but I'm only focusing on one of them. I'm only focusing on the negative square root of the 2. As opposed to what we see right here. Notice in this one, it says positive or negative. So when I ask myself, what would I multiply by itself to create an 81? 9 times 9, 9 times itself is 81, but negative 9 times negative 9 is also 81. And this says, hey, I'm concentrating on both of them. I'm concentrating on the positive and the negative of that square root. Now, on this one, I want to point out something here. Notice here that these two look very much alike. However, okay. Notice these two look very much alike. However, there's a distinct difference between the two. And the distinct difference is that this says I'm going to add the 2 first and then take the square root. This one says I'm going to take the square root of each and then add them. So I need to be very careful about the order that I do this. This one again says let's add them up first and then take the square root. So when I add them up, 36 and 64 will give me 100, and the square root of 100 is 10. As opposed to what we see down here. This one says I'm going to take the square root of each first and then I'm going to add them up. The square root of 36 is 6, the square root of 64 is 8, and 6 and 8 gives me a 14. So you can see that I'm getting 2 entirely different answers here. So we have to be very careful about the order in which we do these whenever there's an addition in there. Now what we're about to see in the next video is that when there's a multiplication, things are entirely different. But when there's addition in there, you do need to be very careful about this. So I hope this helps with the basics of radicals. And again, the idea that you've got 3 different types here, and you need to be very careful about what you're seeing. There are 2 numbers that you can multiply together, 2 numbers that you can multiply by themselves to get the number that's underneath the radical. And depending on which symbol you've got sitting in front of you will determine whether you're talking about both of those square roots, only the negative square root, or only the positive one, which indicates the principal square root. I hope that helps. Have a great day.